Hi all. So in this particular video, I'll be talking about the accelerated motion, that is module 3, and I'll be talking about the second lesson, which is motion with constant acceleration. Okay, so what are the objectives? There are six objectives which we need to learn. Identify the shape of a position time and velocity time graph for an object with constant acceleration, and calculate the acceleration from the slope of the velocity time graph and the displacement as an area under the curve of a velocity time graph. So the first three things, let's talk about that. Okay. So according to our textbook, um, we know that what is average acceleration and what is instantaneous acceleration. There are two types of acceleration. One is average. One is the average acceleration, which is talking about average acceleration is talking about the change in velocity delta v, which is vf minus vi, divided by in a measurable time interval. Okay, so which is delta t, which is df minus ti, isn't it? So here I can find out the average acceleration for a particular amount of time, which can be, for example, which can be between 2 to 4 seconds. I can find out the average acceleration. The slope over there, if you draw the slope over there, I can get what? The average acceleration. Whereas for instantaneous acceleration, it is for a particular instant of time. For example, they are talking about at 2 seconds. What is the acceleration over there? So for that, we have to draw a tangent over there, and then we have to draw the slope like that. I have explained it already. If it is a curve, remember we have to draw the tangent over there, and then we have to draw the slope, and from that we have to get that particular uh, that for that particular time, the instantaneous acceleration. Now coming to acceleration with constant speed. That's what we are studying right now. It is a motion with constant acceleration. So page number 63. So we are going to study. So motion with constant acceleration. Sorry, position with constant acceleration. What is it? In such cases, in a position versus time graph, in a position versus time graph, which is here position x and here it is time, acceleration, how it is shown? It is shown like this, okay, as a curve. Even if it is a constant acceleration, it will be like a curve itself, constant acceleration. Hope it is clear. It is a constant acceleration. You can jot down the important things. So in this case, can you see that the object experiences constant acceleration? If an object experiences a constant acceleration, its velocity changes at constant rate. How does its position change? The positions at different times of a car with constant acceleration are graphed in this particular graph. The graph shows the car's motion is not uniform. You can see that in all the cases, the graph is not uniform. Can you see that? This green line, that is the motion. Okay. The displacements of, for equal intervals of time on the graph get larger and larger. Can you see that over here how it is? Over here how it is? Like that it goes. As a result, the slope of the line is gets steeper as the time goes on. So if you look into the slope of this particular part over here, you can see that this is 10 meter per second, whereas in this case it is 20 meter per second. It is just slope by drawing the tangent, which we have already studied. Yeah. So for an object with constant acceleration, the position time graph is a parabola. So remember, for constant acceleration in a position, for a position time graph, it will be looking like a parabola. Okay, remember that it is a parabola. Now, if it is a velocity time graph for constant acceleration, how does it look like? It should be a straight line. Okay, it should be a straight line graph if it is a constant acceleration. So it will not change the slope wherever you take the slope. For example, if I took the slope here, it will be 10. If I take a slope over here, again it will be 10. It will not be changing like how it was here. Okay, hope you understood that. Now, coming to, yeah, that is shown here. The slope used to calculate acceleration, which is, look at this, the slope, how they have taken. In this case, the slopes from the position time graph shown have been used to create the velocity time graph on the left. For an object with constant acceleration, the velocity time graph is a straight line, as I mentioned. Okay, so remember that. Now, in this case, velocity, from a velocity time graph, we can find two things. First one, velocity time graph. If you take the slope of the graph, if I take the slope of the graph, I'll be able to get acceleration. Okay, I'll be able to get acceleration. If I'm taking the area under the graph, okay, for example, the area under the graph, this is the area. It looks like a triangle. So area of a triangle is half BH, half multiplied by base multiplied by height, which is giving me what? The total distance traveled. Total distance traveled by the body. Hope you understood that. Okay. So I remember that the area under the graph gives the displacement on the right. Can you see that displacement or the total distance traveled? You can write displacement itself. Why? Because it is more accurate. Displacement is better. If I write speed time graph, I will write distance traveled. If I draw velocity time graph, I will be able to write displacement. Okay. Hope you understood that. Now, what is the shape of the position time graph for an object traveling with constant acceleration? Parabola. Okay, parabola. And what is the shape of the velocity time graph for an object? Straight line. Hope you understood this much. Now, coming to velocity with average acceleration. Velocity with average acceleration. So here, in this case, um, we learned about acceleration equation, isn't it? Acceleration is change in velocity divided by change in time. Remember that. What is acceleration? Change in velocity divided by change in time. Where we know already regarding velocity. What is it? Change in displacement divided by change in time. There are two equations which we have studied, isn't it? And we all also know that v is equal to, I can write it like xf minus xi divided by t. Yeah. And here it is a is equal to vf minus vi divided by t. So if I rearrange this equation, take the t to the other side. So it will become multiplication. Here it is division. So if you take it to the other side of the equation, which is the opposite of the equal to, what will happen? A multiplied by t will come. Yeah, at will come. A multiplied by t is equal to vf minus vi. Can you see that? There is this equation. Yeah. So here I can write, oh, I forgot delta t. Yes, delta t also you have to write. A multiplied by delta t, delta represents change. So I have to write. So you can get final velocity with the average acceleration. When you rearrange this equation, what will happen? You take it to this side. Here it will become plus. So Vf is equal to Vi plus A delta t. So this is the first equation from the derivation of this particular question. Okay, I mean, but this particular equation. So if I'm looking for the final velocity with average acceleration, so remember, final velocity I can find out with the help of this particular equation. This is also for acceleration as constant. These equations are used whenever the acceleration is constant. So it is called uniform acceleration equations. Acceleration equations. Okay, there are four which you will be studying. So first one, we know that Vf is equal to Vi plus A delta t. This is the first equation. Okay. Now, second equation we're going to study. So with respect to this, we have to do these many questions. 16. A golf ball rolls up a hill towards a miniature golf hall. Assume the direction toward the hall is positive. it is positive. If the golf ball starts with a speed of 2 meter per second, so you have to look for the question, picturize it in order to understand it better. So if the golf ball starts with a speed of 2 meter per second, so it is starting with a speed. What did you understand? It is VI. Okay. Remember that it is starting speed. Starting speed means initial speed, which is represented as VI. Write it like that. And slows at a constant rate of 5 meter per second square. So which is look into the unit, it is acceleration. Okay, and it is constant. So I have to use constant acceleration equation. What is its velocity after 2 seconds? So after 2 seconds, what is its velocity? So time is given. So how will you find? T is a question they are asking for. So remember, in this case, the what all things are provided? It is rolling upward hill towards a miniature golf hall. Assume the direction toward the hall is positive. So that is positive taken. If the ball starts with a speed of this much and slows at a constant rate, what is its velocity after 2 seconds? After 2 seconds, what is its velocity, which is Vf? They are asking for Vf. So we know the equation. As per our equation, Vf is equal to Vi plus A delta t, isn't it? So in this case, they have mentioned that it is slowing at a constant rate. So you need to understand it is a minus A. What is minus A? That means it is deceleration. Constant deceleration is happening. Yeah. So it is slowing. Slowing, you can say that it is deceleration. Yeah. So in this case, I have to know that it is minus A. Whenever it is slowing, it is minus A. So you have to put that values with minus wherever it is required. So what is the speed? Speed is positive, which is going upward, which is positive itself. So 2 plus, and what else? Slowing at a constant rate. So minus 0.5 multiplied by what? 2. 2 is the time. So once you do it, you will be able to get 2 minus 1, which is 1 meter per second. That's how it has to be done. Okay, 1 meter per second. Now, B part. What is a golf ball's velocity if the constant acceleration continues for 6 seconds? Now, the time has changed. Now, they are asking for the golf ball's velocity if the VF again they are asking by changing the T. Okay, so again the same equation, VF is equal to VI plus A delta T. So here in this case, 2 same starting with the same initial velocity. So 2 again plus minus 0.5 multiplied by the acceleration also is constant, isn't it? So minus, it is slowing down. So minus 0.5 multiplied by 6, which is how much? uh, Solve it, use the calculator, and you should be able to get this as the final answer, which is minus 1 meter per second. Hope you got it like that. Please check your answers. Okay. Now, one more question is there, part of it. Describe the motion of the golf ball in words and with the motion diagram. So, in words, what is happening? The ball's velocity simply decreased in the first case. So, decrease in the first case. In the second case, the ball slowed to a stop and then began rolling back down the hill. Okay. So, in this case, what is happening? Both the cases describe the motion of the golf ball in words with the motion diagram is what is mentioned. So first part, look at that. In this case, 1, it is 1 plus 1 it is, and here it is minus 1. Yeah. So in both the cases, you could see that here it was moving with positive, this is positive, plus 1 it was moving, then stopped and came back after 6 seconds. I mean, this is for 2 seconds, and after 6 seconds, what is happening? It is coming back. So, how you will be drawing? in the second case, a ball slowed to a stop and then began rolling back down the hill with respect to the values you are talking, +1 and -1. Can you see both of them? So here, what happens in both the cases, um, this is going up and coming down after stopping. So +1, -1. Now, what do you need to do? You have to draw it as a what is that? Motion diagram. Okay, so in this case, you need to understand for the first second what is happening. The speed is increasing. You can see that now it has a little bit decreased because the distance between them has decreased, and now again decreased, again decreased, and stopped, and coming back and increased. It is going to increase. Like that, you have to draw the motion diagram. Okay, hope you understood all these parts. So let's talk about next question, which is the 17th one. A bus traveling 30 kilometer per hour. So remember, 30 kilometer per hour, which is not our unit. So you have to convert that first. So kilometer per hour, how will you change it? Kilometer per hour, 1 kilometer is 1,000 meters. So 1,000 meters divided by 1 hour consists of how many seconds? 1 hour is 60 minutes. 1 minute is 60 seconds. So 60 multiplied by 60 will give me to the second. So 3,600 calculated. 60 multiplied by 60 is 3,600 seconds. Okay, so if you solve it, you will be able to get that particular 10 divided by 36, or solve it in the calculator. So once you get it, you will be able to get it in meter per second. So first you do that part, and it has a constant increase in speed of 1.5 meter per second square. Look into the unit. Constant increase in speed. Increase in speed means acceleration. And look at the unit. Yes, again, it is talking about acceleration only. So acceleration. What is its velocity? 6.8 seconds later. So time is provided. Delta t. This is delta t. And here they are talking about the speed. A bus traveling 30 kilometer per hour east has a constant increase in speed. So this is the velocity initial. It is. Okay, so velocity initial is there. Now, what we have to do? Velocity final is what they are asking for. So, how will you do it? Look at that. So, first of all, you have to convert it into this particular, what is that called? Meter per second. Okay, do that part. And after that, solving, you will be able to get which equation I have to use? Again, Vf is equal to Vi plus A delta T you have to use. So Vi is how much? Vi is 10 divided by 36 I'm writing. Solve it. Plus A is 1.5 multiplied by delta T. Delta T is 6.8 seconds. So once you solve it, you will be able to get this as the particular answer. Now, coming to one important part, which is we will be getting the answer in meter per second. You can write it in meter per second, absolutely fine. This is not what is in meter per second, so you have to be a little bit careful with that. Hope you understood. So this is in kilometer per hour they have solved. So since we have converted everything to meter per second, the final answer you are going to get is in meter per second. Okay. Sorry. Yeah, you will be able to get in meter per second. Okay, now coming to the next question, which is 18th question. Okay, if a car accelerates from rest at a constant rate of 5.5 meter per second square north, how long will it take for the car to reach a velocity of 28 meter per second north? So if a car accelerates from rest is mentioned. So velocity is 0. Initial velocity is 0. Okay, you have to understand that. Picturize it. So the car was in not moving in the beginning, so velocity is 0. Now it is increasing the speed at a constant rate. So it is constant rate means constant acceleration. Okay. which is 5.5 meter per second square north, how long will it take for the car to reach a velocity of 28 meter per second north? So velocity final is mentioned here, meter per second. Now they are asking for how long. How long means time they are asking for. Okay, remember that. How long means time. So you have to use the equation. Which equation you have to use? The same equation. Vf is equal to Vi plus At. And over there, T is equal to, in terms of T, you have to apply it, or in the calculator itself, you solve it, and you should be able to get 5.1 seconds. Okay, hope you understood that part. Now, coming to next one, always check for conversions if there is any conversion required or not. Now, next one, a car slows from 22 meter per second to 3 meter per second. So, slows from is mentioned. So, it is slowing, it is slowing down. So, this is the velocity initial and this is the velocity final at a constant rate of 21 meter per second square acceleration. How many seconds are required before the car is traveling at a forward velocity of 3 meter per second? At a forward velocity of 3 meter per second. Okay. So here we know that 3 meter per second is the velocity final. How many seconds? Time is the question they are asking for. So again, the same way you have to do. But remember, in this case, the VF is 3 and VI is 22 and it is slowing down. So you have to do minus 2.1 in the equation. Okay, so when you do 22 is equal to, oh sorry, 3. It is slowing down, right? So it is 3 is equal to 22. V initial plus minus 2.1 multiplied by t. T is how much? We don't know. We have to find out. That's a x. Okay, I'll write x. So apply that in the calculator and solve it. Hope you will get 9 seconds. Okay. So that's how it has to be done. So we have finished till the 19th question, 16, 17, 18, 19 done, which is the part of the EOT. Which part? In this one, question 3, free response, question 3, you can see that 16 to 39. We finished till 19 only. We will do the next parts in the next coming videos. Thank you.